Good day, everyone, and welcome back. My name is Gabriel Nahera, and I am a member of the planning committee for this workshop, and I will be moderating this panel discussion where the focus is going to be on existing collaborations programs as students transition from K-12 to undergraduate level, including retention. And our four panelists will be Michelle Reeves, Executive Director of DAPSEP, Christine Foreman, Professor and Associate Dean, Montana State University, and Brooke Burhani, Assistant Professor and Undergraduate Program Director, Florida International University, and then Bipal Nepal, Professor at Texas A&M University. Before I bring in the first speaker, I'd like to thank Dr. Sidbury for that very informative presentation. So now it gives me pleasure to introduce Michelle Reeves, Executive Director, DAPSEP, who will speak on programs that address transitions from K-12 to undergraduate education. And I remind the participants to ask your questions in the Q&A. And with that, join me in welcoming Michelle. Michelle.
Thank you so much. Good morning. I guess we have about a couple more minutes on the morning, but good morning, good afternoon, everyone. My name is Michelle Reeves. I'm the Executive Director for DAPSEP. DAPSEP stands for Detroit Area Pre-College Engineering Program. Next slide, please. We are a nonprofit, 46-year-old nonprofit that has been focused on increasing the number of underrepresented students who are academically prepared and motivated and excited to pursue STEM degrees. We serve about 13,000 students per year and in a number of ways. So it's through partnerships with universities and our corporate partners, where we not only have the students engaged in STEM disciplines, we also want to make that connection to post-secondary education and as well as careers in STEM. So through those various partnerships, we are able to engage the students on those different levels. Next slide, please. And as I talked about the various ways of engagements, in 1976, we started out with about 250 kids in a summer program. Our founder saw the need of engaging young people in a more immersive program. And at the time, it was just engineering, to try to get them excited and motivated to pursue an engineering degree. Since that time, you can see we have expanded through starting as early as pre-K. So from 4 years old all the way to 12th grade, we do primarily Saturday programs, 6-week Saturday programs on universities or corporate campuses. We also do large scale engagements where we will invite 1,000, 1,500 students to one location to try to spark that interest in some form of STEM so that they can continue another class with a longer engagement. We do multi-year programming where we will take a group of students over 18-month to 2-year period to have that cohort model where they are having consistent engagement with the various curriculum as well as our corporate partners. We even go into the workshop, go into the schools and do what we call pop-up workshops where we'll take over a classroom. We know there's a lot of different ways that we must engage students because as we have found over time, students' time is taken up by so many different things. And so we are trying to reach students where they are. And even we do a trainer-trainer model with some school districts where we are training their teachers on science research curriculum. Next slide, please. And so we look at our methodology. So we start as early, as I said, we start as early as pre-K. Dr. Sidbury, in her previous talk, she talked about the need for the early intervention. And we have found that when we started at the high school level, we moved to middle school. And now, as you can see, we're down to pre-K because we know as soon as possible, as early as possible, we need to get the students excited. So we start at that pre-K level through third grade, just trying to get them to be excited about STEM. That's when, you know, as you know, the younger they are so excited and eager to learn. So we want them to be comfortable with the language. So they hear those scientific terms. So they're not intimidated by them when they move to the higher grades. Even if they don't understand the full concept, we are exposing them to these concepts so that they're very clear and again, not intimidated by it. So once we move into the 4th and 6th grade, we're starting to prepare them for what it takes to be at the middle school level. So everything we do is really a couple of steps ahead of the grade level where we want where the student will be. So they're doing a lot of hands-on, they're engaging in a lot of group work. By the time that we get to 7th grade, 7th through 9th grade, we're trying to prepare them for high school. So we're stretching them a little bit more. At that point, there's a variety of programs, whether it's coding, engineering, robotics, math. There we have provided a lot of different educational programs, and it's where a student can, you know, decide if they want to, what they're interested in. A lot of times we tell them this is a time when they can explore. You know, this is where it's nothing about our programs look like your normal day of school. And so students like the fact that they can learn without the fear of repercussions, where, you know, they're not trying to do it for a test. They are really trying to explore, get them excited, just ignite something in them, so that they know what is possible going forward. By the 10th and 12th grade, most of these students have identified what area or what type of interest that they have. A lot of times we are then really trying to refine and hone those skills and really prepare them for what they will encounter as a first-year freshman or once they get to college. A lot of things that we do when we talk to our students, especially some of our alumni, they talk about the experiences and opportunities that they had in our program that really prepared them and advanced them once they got to college, because they had already seen the terms, they had done an assignment, they had been in that classroom, maybe even with that professor. So it really changes the dynamic when a student then enters into college for the first time. Next slide, please. And DAPCEP takes a unique approach. One of the things I think that's made DAPCEP so successful in how we engage our parents and students is that we engage both parents and students. We are not a drop-off program. It is an engagement where the parent has some involvement in a student's engagement. So the students is part of the program, and then through our various partnerships, we partner with the K-12 education system. So whatever that school district that the child may attend, typically is some form of a partner with us. And then I've talked about our post-secondary education partner. So we partner with at least 11 universities in the state of Michigan, and then a couple outside of the state of Michigan where students are taking classes on their campuses. And again, that changes a student's understanding of where they should be and what their future could look like when they've already been in those universities. And then with our corporate partners, that partnership, many of our corporate partners, again, the students are now taking classes in their offices. So the corporate students can then see themselves, they see the full circle. So they can see a person who looks like them, has done came where they, have lived where they lived, sat in the same high school seat that they sat in. And then they can see themselves in that particular career. And so what that does, again, is allow the student to see themselves and help them visualize where their journey, what their next steps of their journey. Next slide, please. Part of our success with our corporate partners and some of our university has been because the alumni that have come through the program. We have over 70,000 students that have come through the DAPCEP program. At our last survey, 68% of those students talked about are actually in a STEM career. And then 97% of them then spoke to how DAPCEP prepared them for success. And because their employers can see the preparation that DAPCEP has provided, whether it be from the automotive companies, energy companies. They then are willing to partner and support our efforts to help them diversify their pipeline. Because as you know, everyone is working towards how do we increase the pipeline of students that are in STEM, and they understand the need for diversity in that pipeline. And so DAPCEP has been able to show our impact with the students that we engage, and that could be part of their future workforce. Next slide, please. Some of the current students that we engage, our evaluations indicate that 89% of the students are learning new things. 70% of them want to take more classes in STEM, and their test scores are increasing. And then we have that nearly 100% high school graduation rate. And we think it's really impactful for the students to want to learn more about STEM. That's the goal. We want them to see their space in this discipline. We know how needed it is, and how the diversity of thought is needed as well, as we are looking at the future in technology, engineering, and especially medicine. Next slide, please. Some of the strengths that we have and lessons that we've learned. It's important that our programs, the students learn the theory of the discipline, but we have to show them the real world application. It is imperative that they can see that tie. That's why it's critical when we have the educational pieces, we tie it with a corporate partner so they can see the full circle. What does that mean? Sometimes when the students are in class, they can't see themselves at the end. And so having that corporate partner is key in that sense. All of our courses are hands-on, they're engaging. Again, we don't want them to look like their everyday classroom. So it's a different way of learning. And that's one of the things I think that, again, that's key. We are teaching the students to think differently about some of the key concepts that they've seen in school. And it's imperative that we continue to partner as we look at the opportunities going forward. It's imperative that we continue to look at trends. Technology is changing every day. So we are constantly changing our curriculum, making sure that the students, that it is tied to what is a current trend. And at baseline, teaching them the foundational skills that will transfer no matter what the trend is. So that's critical for every sector of business. Next slide. And some of the key takeaways, DAPCEP moves from novice to expert. We do a large group. We try to expose as many students as possible and help them refine once they get to the older age, high school, really refine their skill sets to ensure that they are prepared for the next level in their journey. Next step, next slide. And that is all. And I thank you so much. And I look forward to the questions at the end of the session.
Well, thank you very much, Michelle, for that informative presentation and for talking about the challenges, opportunities, and especially the impact that DAPCEP is making. I noticed that in the chat room, you have several alumni from your program joining us in this workshop. So that speaks to the testament of the effectiveness of your program. It gives me pleasure now to bring on our next panelist, Christine Foreman, who is the professor and associate dean, Montana State University. And Christine will speak on programs that address transitions from K-12 to undergraduate education. Christine.
Good morning. Thank you for the opportunity to be with you all here today. Today, I'm going to talk about two educational pathway programs that help us bring underrepresented students into engineering at Montana State University. Montana State University is our state's public land-grant institution and the largest university in Montana. Montana is a large rural state where 42 of our 56 counties are considered frontier, meaning that they have less than 5 people per square mile. So Montana's higher education landscape is pretty unique because of these large distances, small populations, and relatively low racial and ethnic diversity. For example, American Indians are the largest minority population in Montana, representing nearly 7% of our total population, which compared with about 2% nationally. Montana also has the highest percentage of rural schools in the nation, and is home to a large percentage of economically disadvantaged youth. Research shows that students from these rural, economically disadvantaged and Native American communities have lower educational attainment at both K-12 and post-secondary schools, which is why we've really focused our efforts on the two different educational pathway programs that I'll speak to you about today. Next slide, please. Empower, which is our engineering minority program in the College of Engineering, supports diversity and inclusivity in engineering through student support and engaging K-12 students in the STEM pipeline. The Empower program has been in existence for over 30 years, and we're lucky enough to have an actual Empower Center, so a physical space that provides community building, tutoring spaces, community areas, as well as we have a new American Indian Hall on campus. Next slide, please. The first program that I'm going to talk briefly about today is our NIH Bridges to the Baccalaureate program, calling it the Power of Collaboration, Building Bridges for the Success of Montana's Underrepresented Students. Bridges is an academic enrichment program for students from Montana two-year colleges with an emphasis on tribal colleges. Bridges helps tribal college and community colleges students prepare to transfer into biomedical engineering, behavioral, and other health science fields at a four-year institution. Bridges is coordinated in collaboration with our American Indian Research Opportunities Program, which includes an advisory board of tribal college and community college faculty, as well as our MSU faculty and staff. Next slide, please. Our program begins with a two-day orientation, introducing students to campus, program staff, their faculty mentors, and laboratory research facilities. It also provides students with a really thorough review of the summer program goals, expectations, requirements, the daily schedule, and other student resources. Because most of our Bridges students come from remote, closely knit rural communities, they've never spent significant time in a city, which some of you may find amusing that we consider Bozeman a city of 50,000 people or a large campus. But without this orientation, the students quickly were becoming overwhelmed and frustrated. So that orientation really provides an opportunity to give tours of campus, dormitory and family housing, because many of our students will come to these programs with family members, as well as tours of the Bozeman community to increase the students' comfort at MSU and to empower them to effectively seek out resources that are available to them. Over the years, this program has been going on for about 20 years now. And over the years, we found that this two-day orientation is really critical. It provides time for participants to share their expectations and goals and help really build and develop a cohesive cohort, which is critical in this process. We offer a laboratory skills program, so they get trained in hypothesis development, design thinking, protocols, biosafety, research ethics, and technology training. We also have a daily university skills seminar that accompanies the program. And these will be things like topics in professional presentation and communication skills, resiliency, student well-being, including mental health, nutrition, accessing student support services such as financial planning, and peer-to-peer mentoring. Our summer program concludes with a celebration at MSU where students present professional research posters to their family, friends, colleagues in the greater MSU community. And because family bonds are particularly important to Native American and Latino students, the symposium enables these students to share their achievements with their extended family members. We've been doing this in person and with the pandemic virtually so that they can carry this pride home for what they've accomplished over the summer and then bring that back to their communities as well. Next slide, please. Some of the lessons that we've learned. The Bridges program has engaged Native American and other underrepresented students with meaningful research experiences for nearly 20 years now. It's also provided a critical and valued mechanism for enhancing our relationships with tribal college faculty, administrators, and students. The group and the program has been instrumental in sustaining these collaborations and creating a level of trust with tribal communities that helps ease that transition to a four-year program at Montana State University or other four-year institutions. We've found that math competence, as many of you have, is really critical to our students' success in these Bridges programs, with the lack of preparation being a strong impediment towards degree progress and completion for our trainees. Over the years, we found that we really need to set minimum levels of competency for these students to be successful. Once they get that, then we offer support to bolster their student success. So Montana has a free, self-paced online mathematics curriculum known as EdReady. Past experience has shown that 86% of the students that worked with this program improved their math placement scores after only 20 hours or less of some instruction. So it sort of meets the students where they are. Instead of giving them concepts that they're familiar with, it challenges them with ones that they're not and gives them that ability to feel confident in moving forward with their math skills. Often rural two-year colleges don't offer these upper-level math courses, so the Bridges students come in with math anxiety. And so in order to counter that, we provide individualized math instruction for these summer students. We use developmental math faculty that are experienced working with Native and other underrepresented students. So they're very focused on that individual instruction and bringing the students what they need. We have peer problem solving sessions and we incentivize participation. Another critical element of our student success is creating that cohort. So students work and learn together in a welcoming environment. We have them create LinkedIn accounts right away and a shared messaging board so that day one, they start to feel like they're part of this cohort and they have that community around them. We clearly define expectations on day one. That helps head off misunderstandings. Our research mentors not only help students develop skills in the lab, but serve as a guide to the hidden norms of college life. These complex interactions can particularly overwhelm first-generation students or those from lower socioeconomic groups that may not have family role models that have gone to a four-year institution. College is hard, right? Peer mentoring helps provide relatable, trusted support. If you could move to the next slide, please. There's a quote from one of our students from the Fort Peck Tribal College. I think she says it best. Students, especially Native, minority, and first-generation students, rely heavily on one another for peer support. Students involved in the Empower Peer program have developed a sense of family, which serves as a buffer with regard to being away from our own families and communities. Many a night we have sat together working out chemistry, physics, math, and engineering problems together, not to mention the speakers and events we host for practical conversations about applying for grad school, getting scholarships, conducting research, and presenting. These are pursuits that for many of us were never in the cards. Now, I am at a four-year university, and the support I receive through the Empower Peer Mentoring program has changed my level of opportunity and my ability to maintain a positive and beneficial path. Next slide, please. And in my waning seconds, I just wanted to talk quickly about another program, our Crow Education Program, which was conducted in partnership with the Crow Nation Education Department and Yellowstone National Park, with a focus on place-based, culturally responsive teaching and learning. The students learn about cultural competencies and our STEM graduate students learn about cultural competencies and serve as mentors, bridging that gap between fourth graders and faculty. This age group is a critical demographic in terms of establishing expectations and confidence. This age was also noted by Dr. Sidbury in her opening talk this morning. Next slide. Excuse me. Program successes, and these are successes from the Crow Nation teachers. that the partnership engaged the kids in science beyond the textbook. They were doing real world science, as well as supporting the teachers' science knowledge, which allowed them to bring more science into their classrooms. It expanded the students' perception of science and scientists and engineers, and it really reinforced those cultural connections. Next slide, please. And my last one. So our lessons learned primarily is that the community members need to have a seat at the table in terms of designing those project aims and goals. If the needs of the community are not centered in the programming, then the program won't be sustained, even if there's adequate funding. So funding is an issue, but probably not the most important one when we're thinking about making these culturally relevant connections for these pipeline programs. Thank you.
Oh, thank you very much, Christine, for that very informative presentation about your programs. I want to commend you on the focus on the family culture and its importance in the success of the student. What I'd like to do as a reminder, please, we'll be, after the last presenter on the panel discussion, we will be opening it up for Q&A. So I encourage all participants to put their questions in the Q&A section over on the right-hand side. So now it gives me pleasure to introduce Brooke Burhani, Assistant Professor and Undergraduate Program Director at Florida International University. And Brooke will speak on programs that address transitions from community colleges to four-year institutions. Brooke.
So Brooke, you just need to unmute
turn
yourself.
Your mic on, Brooke.
If you toggle the microphone icon in your bottom menu bar.
Can you hear me now?
Yes, we can hear you.
Okay, I had a second microphone button off, but that one was on, so two issues. But thank you all for allowing me to be a part of this exciting workshop. I'll be speaking about programs that address transitions from community colleges to four-year programs. If we go to the next slide, what I wanted to do, though, before I share three exemplary programs, and I'm sharing them from different parts of the country that I've been familiar with for some time, I wanted to give, for the first half of this presentation, a broader landscape of the picture as it relates to community college students and why this is such an important population for broadening participation in engineering. And the first thing I wanted to point out here is that community college students really are indicative of the overall U.S. population. So quite often the conversation in engineering is around parity and how we can move students toward more engineering students of color, more women that look like the U.S. Well, the fact of the matter is that conversation is typically centered around the four-year institutional context. Obviously, typically, this is data coming out of mostly four-year PWIs, predominantly white institutions. But it turns out community colleges are already on par with the U.S. population. And I think that's an important data point, because if we're looking at ways to expand the engineering population and diversify it, we really should focus on community colleges. And the data generally speaks for itself right here on this slide. If you could move to the next slide. The other reason that community colleges, I think, are important to consider in the engineering context is not only are they enrolling across all majors a diverse population that reflects the U.S. population, but they are graduating numbers that are already on par with students representation in the overall U.S. population. So in the previous slide, you saw numbers like 14% Black, close to 20% Latinx in that population. Again, if you look at the numbers of graduates, people who are earning AS degrees, associate of science degrees in engineering, those numbers do already reflect the overall population of the U.S. That contrasts greatly with what we know at the four-year level. And so once more, if we're already doing such a great job at the community colleges, why not focus more? And my statement generally is that we should focus more, and that we have not typically done so. If we can move to the next slide. where I think the conversation can also move, though, and where I'll be talking more today, is not so much about the community college enrollment or AS degree completion rates, but more about the transfer rates. And so what we do know is that Black and Hispanic or Latinx students typically transfer to four-year schools at rates that are lower than their white and Asian counterparts. So the graphic on the left shows numbers that are around 28 or 37% for Black and Hispanic students respectively, compared to around close to 50% transfer rates for Asian and white students. And I think generally speaking, across all racial and ethnic groups, transfer numbers need to improve, but certainly for these populations, and indeed for Native and indigenous populations as well. And I apologize that that data was not available on this graphic, but that data for those populations certainly are important. So transfer rates generally are low. And in fact, on the right side, the Community College Research Center has some great data that shows that out of 100, so there's a 31% overall transfer rates across all ethnic groups, across all disciplines. And in fact, only 14% of students who start at a community college will ever earn a bachelor's degree. So again, it's not an issue of enrollment or AS degree completion. It's really about transfer and baccalaureate degree completion. And if you move to the next slide, what I think is really important to emphasize is that we in the engineering community, if we can just go back one more, we in the engineering community have typically not tracked transfer numbers in engineering, particularly along the lines of race or ethnic populations. And so that's critical, because typically you can find data on freshman enrollment numbers broken down by race, ethnicity in engineering across engineering fields. You won't typically find those numbers published along the lines of transfer. So I think this speaks to the fact that we as an engineering community have typically not looked at the transfer pathway as a pathway that's viable and that really represents something that's as important as the freshman pathway, first time in college students. So we really need to elevate the issue of transfer in engineering to the same level as we do speak to students who are coming directly out of high school into four-year institutions. And with that being said, we can move right to the next slide. So I'll spend the remaining 5 minutes or so talking about 3 exemplary programs that do address transitions and transfer. And the first one is out of the City Colleges of Chicago, and Gabrielle and I have spent a lot of time talking to our colleagues there. Doris Espiritu and her colleagues have developed a holistic and programmatic approach to transfer model. Based right in Chicago, I do want to point out that the Wright College is a Hispanic serving institution. There are a large number, as you've already seen, of community colleges that do have a much more diverse population than our four-year schools. Without reading this verbatim, you can see some of the features of the model. It includes engagement with four-year schools. So Wright College has a number of four-year partners in the greater Illinois area, but they also include transitional programs coming out of high school into community college. And that's important because we know from the data that there are a number of students enrolling in community colleges that are taking developmental math, college algebra level courses, and need to move to the place of calculus proficiency if they're ever going to earn an engineering degree. So that bridge program is critical. What I also found really fascinating about Wright College is that they've already aligned their curriculum to be as demanding as the four-year course partners courses. So one of the things that I've seen in my data, and I should mention that I have a study that I'm concluding this year that looks at students who are Black students who are enrolling at a community college and in transfer to a four-year engineering program. One of the data points that I've heard repeatedly is that students find that the courses at community colleges, they're surprised when they take similar courses at a four-year school, in that the four-year school courses seem to be more difficult. And there are many reasons that I could say for that, but the Wright College has tried to find a way to make the curriculum equally as demanding so that students are not surprised when they transfer with the level of demands that are placed upon them. Also financial assistance, mentoring, and you can see the transfer rate is pretty impressive. We can move to the next slide. Some of you may already be aware, this has been published in several venues, including the American Society of Engineering Education, Texas A&M's Chevron Engineering Academies. And so this is a great series of partnerships with various Texas community colleges in which students at these community colleges are co-enrolled from day one with Texas A&M. So if they're at Dallas or Austin Community College, they're beginning their careers at these community colleges while also being already admitted essentially to Texas A&M. So they don't have to apply as a transfer student because they've already been admitted to A&M, even while they're taking their first and second year courses at their respective community colleges. And what that does is obviously it removes the barrier of entry so that students do not have to go through the work and sometimes the challenges that are associated with transfer. What's also critical is that there's a partnership with faculty. So there are community college faculty that are teaching those core math and science courses, while the Texas A&M engineering faculty are teaching engineering courses, traveling to the community college campuses and giving students an opportunity to engage with those engineering faculty very early on. What is important to point out, and a little bit different from what I said a few minutes ago, is that students must be calculus ready at the point of entry into the engineering academies. And so what that means essentially is that the students, as they're enrolling at their respective community colleges, cannot be to be a part of this program, cannot be taking developmental mathematics courses. They need to be calculus ready. And so we need to just think about what that looks like for students, depending on their needs, depending on their trajectories, depending on their backgrounds in mathematics, as we think about how to take some of these different types of models and institute them at different types of schools across the country. And I'll move to the last slide at this point. And I'll just point out the A. James Clark School of Engineering at the University of Maryland. Just as a quick disclaimer, I was formerly with the Clark School of Engineering as a recruitment director there. But what I will point out about the Clark School is that they also have employed not just a recruiting team, but an engineering transfer advisor. And that's an important staffing component. When I've talked to many engineering potential transfer students, one of the greatest concerns that are raised is that they don't have someone in engineering that they can talk to about transfer. Many of the advisors that they'll talk to are generalist advisors, and there's nothing wrong with that at all. Essentially, I mean, we have great advisors that represent many disciplines across the campus. But we do know that engineering has its own set of requirements, and so having an engineering advisor already employed full-time at the School of Engineering in the four-year space gives the students a direct point of contact. There are also engineering ambassadors who physically will travel to the community colleges, or during COVID might do virtual visits to give students a chance to meet four-year students ahead of time. Next month, they're also hosting what's called the Maryland Engineering Transfer Alliance Conference. This gives students and rather faculty and staff a chance to meet other colleagues from across the state, including the four-year partners. And the last thing I'll point out is there is an existing scholarship program for students with need called the Clark Opportunity Transfer Scholarship Program. My time is up, and I'll be happy to take questions later. Thank you so much.
Thank you very much, Brooke, for that presentation, and look forward to the Q&A discussion at the end of the panel discussion. So with that, what I'd like to do is introduce Bipal Nepal, professor at Texas A&M University, and Bimal will speak on programs to support retention in undergraduate engineering. So with that, it gives me great pleasure to bring Bipal to the virtual platform. Bimal.
Sure. Thank you, Gabriel. Good morning, good afternoon, good evening, everyone. I'm Bimal Nepal at Texas A&M, and I manage the first generation engineering student mentoring program at Texas A&M. We focus on really freshman students transition from high school to college and then become professional engineers. So next slide, please. So what I plan today in the 10 minutes I have, I'm going to give you some background about the first generation student at Texas A&M, talk about their retention and graduation rate gap between the different population group, and then move on to the mentoring program specifically and how we run that and some of the impact we have found as a result of that program. Next slide, please. So this is the founding team which worked on this program in 2017. Next slide, please. So just to give you a little background about, the first generation student population in Texas A&M, in the College of Engineering, we have about 15,000 or more than 15,000 undergraduate engineering student population at Texas A&M. Of those 15,000 plus, about 20% of them are first generation. So I think it's about as of fall of 2021, we had about 3,400 first generation student in the College of Engineering. That includes from freshman to the senior. And there is a, a racial and ethnic background or breakdown. You can see that, and it's very diverse. And also in terms of male, female, which is about what we have in the College of Engineering. In fact, across the Texas A&M University, about 22% of those first generation engineering students are female, and 78% of them are male. Next slide, please. So this is very important slide I want to really discuss today. If you look at the retention and graduation rate gap between first generation and non-first generation, there is a significant gap you can see between those, starting with the first year retention higher. Next slide, please. So one more data points before we move on to our mentoring program. As many of you know, because you work in the engineering education, so there's a lot of literature there, and we have found through our own research of our internal Texas A&M student, first generation students are very unique in many ways. As mentioned by Christine earlier, because their parents didn't go to the college or don't have an undergraduate degree, they don't have the prior knowledge of what to expect when you go to the college, especially if you come to Edge Large University of Texas A&M. We have about 70,000 students on campus. That's huge. And then, it creates a lot of challenge. And also, many of them are from rural and different socioeconomic background where they tend to work more. And also because they come from rural, not all of them have had chance to do AP courses and things like that. As a result, their preparation at the high school level is also sometimes, can create a challenge for them to succeed in the college. So, so they have both financial, academic, and the experience or prior knowledge challenge when they come to, the college. Next slide, please. So what we're trying to do with this mentoring program, as I said, currently we're focusing more on the freshmen because that's where the biggest challenge is. The goal of this first generation mentoring program, what we call the FGen program, is really, to enhance the experience of those first generation students, both academic as well as social experience on campus. Texas A&M and the College of Engineering have a lot of resources and support system. They provide to all students, including first generation. So this mentoring program is really, trying to leverage those resources and provide a sense of community to first generation students so that they can reach their both, personal and professional goal. And this is like one more layer of support for them when they are away from home. Again, the distinction here is that this is not an academic advising or tutoring program, although some of the mentors might have some, understanding about how the academic advising works, but they are not responsible for that. It is more of the, mentoring than really anything else. Next slide, please. So the way it works is we use a platform called Kronos. Many of you may know this is being used for also in onboarding and other functions. So we use this Kronos where a faculty or staff or peer mentor, they will sign in, they will complete the profile, and also the student or mentee will also complete their profile. So they're able to choose their own mentor, basically based on their choice. Some may be choosing based on their desire, like first choice major, second choice major, or maybe their city, their background, and what have you, right? So, and this is one of the, I guess, the unique aspects of Texas A&M mentoring program compared to some of our peer institute like Michigan and other places. This is a one-on-one mentoring, whether they have peer mentor or faculty staff mentor. This is a one-on-one mentor program, and we assign up to 2 mentees per mentor. Next slide, please. So this is the history of our program so far. As I said earlier, we started this in fall of 2017 when we had about 105 freshmen into the program and about 98 mentors. Nearly half of them were peer mentors. As we move on to the, over the years, our program grew. Not as much as we would have liked it to grow, but at least it's grew by went to 140, 136. But we saw a sudden dip in the program due to, during the height of the pandemic in fall of 2020, right? Everything was virtual. As a result, our program also suffered, even though we had a very strong interest, close to 200 people wanting to be part of the program, but that number went down to 80. But this year, our fall of 2021, we had about 186 as of February 8. And then now the peer mentor number is really low. A lot of faculty staff have shown interest. They're very passionate about helping this group. One thing I must say that our dean himself is a first student and is very, very strong supporter of this program, including Texas A&M president, who is also who used to be dean of engineering and was a strong supporter of this program. Next slide, please. I know I have about 2 minutes left. I want to show quickly the impact. We have been tracking 1 year retention rate as a result of this program. If you look at the two columns here, non-first generation and not connected first generation, meaning first generation students who are not part of the mentoring program. If you look at the 1 year retention data, the gap, non-first generation 91%, not connected first generation 80%. There is about 10% gap throughout, right? Fall 27 all the way through fall 2020. But if you bring in the mentoring program, the middle column there, you see the gap is really narrowed down. So there is about 5% difference in the fall 2017, and that has narrowed to 2% in 18. If you look at the fall 19 data, in fact, the connected or those first generation mentee have better retention rate than the general engineering student population and things like that. So next slide, please. So this is the data tracking 2 year retention. This is just the one data point here. We have fall 2019 student who started fall 19. If you look at the spring 2021, just comparison between first generation students who are part of mentoring program and those who are not. The first generation students who are not part of mentoring program, we lost about 25% of them by the time they came to spring 2021. But if you look at the mentor, the connected student, we were able to keep close to over 86%. I think a little over 15% attrition rate compared to regular first generation, about 25%. Next slide, please. The last slide here is really that we found that the finance is the biggest challenge for them. So what we are doing as a program, we're trying to raise a lot of money through industry donation, partnership, scholarship for peer mentors, and we're very lucky that our both administration and industry partners, alumni base, are very much strong supportive of this program. Thank you so much. That's all I have, and I will be looking forward to any questions you may have.
Well, thank you very much, Bimal, for that informative presentation. And I guess we'll welcome back all of our panelists to the platform, and we'll open it up for a Q&A. And I do have some questions that were generated from the presentations, but we have several from the participants. So let me address the participant questions, and then if there's time left, I'll ask the questions I have. It looks like we have a lot of questions here, mainly for Brooke. So let me start out with that one. The question is, how do we destigmatize community college degrees in graduate application assessments for masters, but especially PhD graduate school acceptance proceedings? Brooke, can you address that?
Sure. So the question is, how do we destigmatize 2 year degrees in these graduate applications?
Yes.
So I think that the 2-year degree, and believe me, I'm no expert in this, but I would say that it is a stepping stone toward the 4-year degree. So it's not that the person would not earn a 4-year degree eventually, but what it does do is it gives the person a sense of accomplishment that really they are already an engineer. So what I would say, it's in great part for the student. It's great for applications to jobs. There are a number of schools that are 4-year schools. I'm not speaking of graduate schools that have applications that essentially say if you have an associate degree, so it opens a lot of doors. And I would say for the graduate schools, what it would also do is it gives the student essentially another it's another accomplishment in addition to the bachelor's degree. So it's not that the bachelor's degree is not already going to be awarded, but this is something in addition to that. I hope I'm answering the same question.
Okay. Well, thank you very much, Brooke.
Thank you.
This next question goes out to Michelle. Can you elaborate how DAPCEP helps with a longitudinal view / approach in helping diverse students along an engineering pathway?
So what we try to do is we connect the students. So we start at, as I spoke about the earliest in high school, through our corporate partnerships. That turns into, many of our corporate partners now have developed internships as related to the potential career options. And so students are now having internships at the junior, senior year of high school. That opportunity really broadens their scope on what that possible career could be. And it also connects them to a particular corporate partner as well as a mentor. So typically it's a paired relationship. So it's a mentor as well as the corporate partner. So as they are now going through, once they finish the high school, those internships typically have the potential to last through college. So they have a mentor who is in that same field, as well as a hands-on, not just filing papers, a real internship doing engineering work that they could relate. And as they are matriculating through college, that definitely springboards them into a potential future full-time career with that potential employer. And if not that employer, they have developed their resume enough that would make them a viable candidate with any other organization.
Oh, thank you very much, Michelle, on that. I have the next question here. I believe this is directed to you, Christine. And what are some of your biggest challenges in working with rural communities, especially so far apart from each other? And I might add, I've been to Montana. I'm sure many of our participants have, and 50,000 is pretty big.
Yeah, that's a great question. You know, students that are coming to us from the Fort Peck Reservation are coming from an 8-hour drive, right? And so even before the pandemic, we've tried to work with virtual engagements as much as possible, right? To be able to bring students, like say for our robotics participation, qualifying tournaments, things like that, we try to do remotely and then have an in-person, because challenges are travel, expense of that. So once you then come to Bozeman trying to find a place to stay, that transition from small rural towns to larger Bozeman type areas is really challenging. And so when we bring students in these programs, so we have to include transportation, right? We have to think about how we're getting the students here, how we're supporting them here, how we're then giving them activities, because they're not going to be going home on weekends, right? They're not traveling back and forth for like those summer programs. So we want to make sure that we're providing that support. And also many of our Native students will come with families. So we have to have family and graduate housing kind of provided for those undergraduate students so that they can feel like they can come, but not have to sacrifice their family in that time.
Oh, that's very, very impressive. Thank you very much. This next question we have here is for Bimal. And let me see, where did I put it? Okay. Oh, yeah, the question here for you, Bimal, is what is the difference between the connected mentors and the other specified mentors, i.e. peer faculty and staff?
Sure. So, I mean, the connected were mentees, right? So I think we're using a term, those first generation students who are connected to a mentoring program, right? So though they are mentee, so within mentors, we have faculty and staff, and we have peer mentors. Faculty staff, they're all from in the College of Engineering, whether they may be academic advisor, they could be research staff, research scientists, or they may be on faculty. So that's a faculty staff. Separate category of mentors, peer mentors. I think one of the presenter mentioned earlier, it might be Dr. Sid Berry. We also see a lot of attraction towards peer mentors, but we have two different category of mentors. But there is no difference. Students are allowed to choose whoever they want. Sometimes we don't have a whole lot of peer mentors, then we suggest them to also consider faculty staff mentors.
Okay. Well, thank you very much on that. Here's a question. I think it's directed to you, Michelle, but I open it up to everyone also. The question is, a large effort in current and past programs are to encourage K-12 students to pursue higher ed, and the data indicates increased enrollment. How can we translate that to more grads and professionals?
I think it comes, unfortunately, it's outside. What happens is, because I've worked at the university level too, I think one of the things that's needed, once the student shows interest, students of color and the university needs to make sure there's enough support systems at that university to help to ensure that that student is successful. National Science Foundation funds several programs, LSAM programs where it does just that. It supports students at their earlier stage through their college career that will then ensure that they are successful, because many students may enter, but because of the lack of support sometimes at the university level, they tend to change their major. So the goal is to ensure that they are completing those degrees as well. And then that will translate into the professional opportunities. And at the college level, those internships or research opportunities need to start at an earlier stage. Many students get just bogged down at the first 2 years because they can't see the light at the end of the tunnel times. The curriculum is it's typically a lot difficult, could be more difficult than they had at the high school level. And so it's critical for the internships, the research opportunities, all of that engagement as to what that career could look like at a younger stage for the freshman, sophomore student. I think that would be key for ensuring that the student graduates and then turns into a professional career. And then we have to, once they get to that professional level, we have to make sure that people who are hiring are ensuring that there's diversity in the workforce, that they are hiring these students who are capable of being in these positions.
Oh, thank you. Does any one of the three other panelists want to add or elaborate, add to what Michelle has provided?
I would just say I agree 100% with what Michelle has said, and that also when we think about this, that we're providing that sort of just-in-time intervention when it's needed, right? So you have to build a relationship with these students so that they feel comfortable coming and talking to somebody, whether it's that peer mentor who then connects them with a faculty or staff member or something else. But you're providing that just-in-time, because often we provide a whole lot of information, like early on, orientation, here you're coming in, but when a student really needs it, then they're kind of confused. And there's like this sort of cold set of information we provide on websites and things. But a lot of these students need that sort of warmer information set, right? Where it's a personal touch, as someone telling them, here, go through this, or talk to this person, or my friend did this. And so I think those things are really critical for this group of students.
Oh, thank you. Go ahead, Bamam.
Just to add quickly, just to focus on first generation student, what we're trying to do at Texas A&M, we encourage them to do like high impact experience, what we say undergraduate research or internship and things like that. So in our scholarship also, we build that program into that. We separate the stipend and the high impact experience stipend. So encourage them to take advantage of those opportunities so that they can stay engaged and improve their engineering identity and things like that.
Okay. Well, thank you very much. We're approaching the time limit for this panel Q&A. Your panel presentation elicited a lot of questions from the participants. Unfortunately, we didn't have time to ask all of them. What I encourage the people who have asked the questions, if you could direct your specific questions in the chat to one of the 4 presenters, and I trust you'll be happy to follow up and answer their questions. So with that, what I like to do is we're going to be taking a short break, but there's we have a polling that we want you to answer 2 questions, and the NAE staff is going to be presenting those questions. So there's 2 questions. Beth has provided a link, and the questions are about your experience so far at this workshop.